Okay, so now we're going to get into graphing specific log equations. So this says we're going to graph log base 3 of x and its inverse, y equals 3 to the x, the exponential function. So we're just going to make a table. It's going to be easier to make a table for 3 to the power of x. 3 to the minus 2 is 1 over 3 squared, so that's 1/9. This is going to be 1/3. This is 1. Anything to the power of 0 is 1. 3 to the first power is 3. 3 squared is 9. So now we plot these points. 0, 1, let's start there. 1, 3, and 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then negative 1 was 1/3. Let's go about 1/3 of the way. And negative 2 is 1/9, which is 0.111111. So this is our asymptote. It's going to go like this. Okay, and then the inverse is going to be a reflection on this line, y equals x. So we could just change the x's and the y's. So 1, 0, 3, 1, 9, 2, 1/3, negative 1, 1/9, negative 2, without even plugging in these values, because plugging in these values is really hard. Log base 3 of, if we plug in 1/9, we have to think, okay, 3 to the what power is 1/9, and that's negative 2. If I say log base 3 of 1/3, 3 to the what power is 1/3, that's negative 1. Log base 3 of 0, 3 to the what power is 0, 1. 3 to the what power is 1, that's 0, and so on. That's how we would make this table. 3 to the what power is 3, that's just 1. And 3 to the what power is 9, that's 2. Okay, so then we can plot these points. 1, 0, 3, 1, and 9, 2. And we get this symmetry here, like that. All right, so then we're going to talk y-intercept, x-intercept, all that stuff, and domain and range. So I need to erase some of this. So domain and range, that's going back a ways. That means domain is what is x allowed to be. Range is what is y allowed to be. So the exponential function, x is allowed to be anything. I can plug in anything I want. Okay, so x, we're going to say all real numbers, which means anything. As long as it's a real number, I can plug in fractions, whole numbers, negative numbers. But the range is limited. The y values go, positive infinity, but they don't cross the x-axis. So they can't be less than 0. Y has to be greater than 0. It can't even be equal to 0. These values can't be equal to 0. And so then with logs, everything switches. The domain, x has to be positive. We cannot plug in negative numbers to logs. Think about it. Log base 3 of, let's just say, negative 9. 3 to the what power is negative 9? We're like, well, okay, maybe x is 2. Well, that's positive 9. Maybe it's negative 2. 3 to the negative 2 is not negative 9. 3 to the minus 2 is 1 over 9. So x has to be positive, but the range can be anything. Because these are inverses, so x and y, domain and range, just switch. So now we have to use that to find the domain of these functions, which means, like, what is x allowed to be if we start changing the equation? And so what we just said is that the input has to be a positive number. So this 3x plus 4 has to be positive, and that's how we're going to figure it out. We just solve this inequality. That's why we solved inequalities back in the first semester. Divide by 3. And so we know x has to be a number that's greater than this, which is negative 1.3 repeating. If I plug in a number less than that, like if I plug in, let's say, negative 2, I'm going to get negative, 2, look at that, negative 6 plus 4. that's going to break the rules of logs. I can't do log base 2 of negative 2. It doesn't exist. So I have to plug in a number greater than that. Notice if I plug in negative 1, it works, because negative 3 plus 4 is positive 1. I can do log base 2 of 1. It's actually equal to 0, because 2 to the 0 equals 1. So anything greater than negative 1.3, and I'm good. This one, all I have to do is set this equal greater than 0, solve, add 5 to both sides, and this is a little bit better number here. Oops, x has to be greater than 2.5. It can't be equal to 2.5, because then we would get 5 minus 5, which is 0, and log base 8 of 0 doesn't exist. 8 to the what power equals 0. There's no possible number. Not possible. But if I make a number greater than 2.5, like 3, then it's possible. If I plug in 3 here, that'd be 6 minus 5. So log base 8 of 1, that's going to be 0, because 8 to the 0 is 1. No matter how much you want to fight that, anything to the 0 is 1. Okay. Now let's talk y-intercept. How do we find the y-intercept of any function? This function is going to look, I don't know, let's just say it looks like this. And it crosses, let's say it actually crosses the y-axis. That means the x-coordinate is going to be 0. So we plug in 0 for x, just like every other function. And what's left, we have to figure out, and we'll have the y-coordinate. So this means log base 3, 0 plus 27. And now we have to evaluate this part. 3 to the what power is 27? Well, that's 3 minus 4 is negative 1. So y equals negative 1. So obviously my scale is a bit bad. This is negative 1. But we could graph this using Desmos and kind of check it out, what it looks like. That's probably what I did in class. So y-intercept is negative 1. And that's basically it for